Get ready to meet what might be the safest chicken flock on Earth. 3 layers of protection, and I'm not counting myself. First, the flock's rooster, Bok Choy, who is always on guard and who once beat back a hawk 10 times his size. His code reviews are brutal. Then there's Loki, the second line of defense, who takes his job as chicken protector very seriously. And the third layer, an AI sentry that is always on and can tell the difference between a protector and a predator. This is the shape of it, 3 servers wired together to watch the coop. Here's what you're about to see. A Raspberry Pi does the looking. A small vision model scores how dangerous the picture is. That's it, just a number. And anything over 0.5 wakes a much bigger model to work out what's happening and what to do about it. Let's run it. Stick around, and later in the video we'll construct this whole thing node by node. The camera's frame crosses the network to a second machine where a small 7B vision model actually looks at it. 6 hens at the coop. Verdict, normal. 0.5 under the bar. The gate scored it quiet, the threshold never fired, and the 35B model never even woke. That's the whole point. The small model eats the boring frames, and the boring frames are almost all of them. Now something moves at the coop. The camera fires, the 7B model looks, and this time it flags it. A dog right by the hens. The score jumps to 0.6, clears the bar, and wakes the big model. The 35B model runs. Verdict, frame, door, weather, all read in at the moment it wakes. A dog near an open coop at dusk. It weighs it. Then it gets a better look. It's Loki, the family dog. The hens have seen scarier, not a predator, a chaperone. Alert stood down. 0.1, lower than a quiet coop. With Loki in the yard and Bok Choy watching the sky, the hens are as safe as they get. And then, the night the camera catches one of these instead. The little model flags it, a raccoon. The score spikes to 0.9, blows past the bar, and the big machine comes up hard. Open the alert. And there it is, in the model's own words. What's happening, whether the birds are at risk, and one concrete thing to do about it. That's a 35 billion parameter model reasoning about a prompt that didn't exist until the moment it fired. So how do you build that? Let's take the whole thing apart and put it back together, one node at a time. 3 servers that cost wildly different amounts. To Krill, they're all just nodes in one swarm. This is Kraken, 2 big NVIDIA cards running a 35 billion parameter model. This is Box, a modest AMD workstation running a 7B vision model. And this is a Raspberry Pi, no model at all. Just a camera pointed at the chicken coop. Start on the Pi, a camera node, a Raspberry Pi camera module. When it fires, it takes a picture and publishes the frame, and whoever is watching wakes up. The door sensor, open. And the run temperature, 87 degrees. Now the Sentry, over on Box, an LLM node, pointed at a 7B vision model running right there on that machine. Watch the arcs. That's data in motion. Its sources live on a different computer. The camera, the door, the temperature, wired in across the network. When any of them changes, this node is invoked. Open it up. Here is the whole idea on one screen. Down here, at the bottom of the settings, is where the node is given its purpose. You are a Chicken Coop Sentry. That's it. That's the whole job description. The prompt is fixed, but the context isn't. Every node wired into its inputs gets serialized into the call at the instant it fires. The frame, the door, the temperature, live. Same node, a different question every single time. That's what separates an LLM node from a chatbot with a script. Over on Kraken, a data point catches the sentry's verdict as it comes across the wire. It observes the model on the other machine. Then a gate. 5 lines of Python. It reads the verdict and turns a sentence into a risk score. A nudge for a normal frame, higher for anything it can't account for, highest for a predator. Watching the verdict. A data point holds the risk level, the Coop's current alert, live, right now, 0.5. Quiet. It reads straight off the gate. And a threshold trigger, the bar, fixed at 0.55. Below it, nothing happens at all. Above it, the big machine wakes. One more source on Kraken, the weather. Not a value someone typed, an outbound webhook that pulls a forecast every time it fires. At the analyst, the 35B model on the big GPUs. It observes the threshold, not the camera. 99 frames out of 100, this machine never stirs. When it does fire, it gets more than the Sentry had. The verdict, the frame itself, the door, and the weather, all read live across 2 machines at the moment it wakes. Last node, the alert. It watches the analyst, and it's what a notification or the door relay would hang off. Turn it on. Every node starts watching the ones it was told to watch, even the ones on other machines, and the weather node reaches out and pulls the forecast. And there's the shape of it, a pie feeding a small model and a small model gating a big one. Toggle the view and the servers drop away, leaving just the nodes and who is watching whom. No controller, no scheduler, nobody calling anybody in order. Every hop is a node observing another node. 3 servers, 2 models, 1 pie, and not a byte leaving the property. That's how you keep a flock safe.